Hello, my teachable students. I welcome you to our special class where we present the simplicity of the science subject. This is a class where I'll be teaching on how to solve problems in mathematics, in further mathematics, in physics, and in chemistry. Like I said, I'll be teaching on science subjects. All right, so I want you to always come with your writing materials to listen to the teaching. So as you are listening and writing, it will help you to have a deeper, accurate, and absolute understanding. Did you understand that? That is why you must come with your writing material so that you can get the best from it. So I will start with mathematics today, and I'll be dealing with a particular topic which I call trigonometric ratio. Trigonometric ratio. So I'll be dealing with all the types of triangle. No, we have 6 types of triangle. We have one, scaling triangle. 2. Isosceles triangle. 3. Equilateral triangle. 4. Acute angle triangle. 5. Right angle triangle. And 6. Obtuse angled triangle. So I will be focusing on one now, which is right angled triangle. I'll be explaining on how to solve problems related to right angled triangle, and I will move to the application that has to do with angles of elevation and depression. So gradually I'll move to how to explain the general angles. Okay, talk about the fourth quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Then I'll move to explaining how to solve problems, okay, related to other types of triangle. So then I'll be making use of the sine rule and the cosine rule. Okay, I will explain all this in detail. Then that will take us to how to solve problems on bearing and distances. So I want you to be very attentive. All these topics I just mentioned now, I will make sure that I take time enough to explain without rushing you. So let us start with right angle triangle. Now if you look at the diagram here, so these are the 4 shapes of right angle triangle. We can have more. All right. So right angle triangle got its name from this small symbol that look like square. Okay, that symbol is called right angle. Right angle, and the value of that symbol is 90 degree. So that symbol that we call right angle, now together we have right angled triangle, right angled triangle. Then the next thing is to talk about the sides of the right angle triangle and the angle. All right. So of course, all angles have 3 sides and 3 angles. Now let's talk about the side. A side is the gap between 2 points, that is between point A and point B. So the gap between point A and point B is called a side, and the gap between point B and C is also called a side, and the gap between point C and point A is called a side. Is called a side. So we have 3 sides. That is a side between A and B, a side between BC, a side between CA. Now let's talk about the angle. Now angle is formed when 2 lines meet. Angle is formed when 2 lines meet. If you look at A, 2 lines meet at A. So those 2 lines they form angle at A. So where they meet. Likewise, 2 lines meet at B. So these 2 lines that meet at B form an angle at B. Though we have angle 90 there, the angle formed there is angle 90, which we call the right angle. And then we have the 2 lines that meet at C. So they form angle at C. So we have 3 angles. We have the one formed at A, the one formed at B, then the one formed at C. Listen very well. We use capital letters to represent or to name angles. Then we use small letters to represent or to name sides. Alright, and every angle faces a unique side. There, you discover that capital letter A, which is an angle, is facing this side. So we name that side small letter A, and capital letter B is facing this side. Alright, so we name it small letter B, and capital letter C is facing this other side. So we name it small letter c. So every angle has its own unique side. Okay, in fact side are subtended by angle. All right, so let us, the next thing is to talk about the next thing is to talk about the naming of the sides. All right, so if you look at it, we have the adjacent side and the hypotenuse side. Let me start with the hypotenuse side. Now hypotenuse side is the side that faces the right angle. The right angle is the symbol that I call square, that look like square there. So any side that face that symbol is called the hypotenuse side, and the remaining other two sides will be called, or are called, the adjacent side. Do you understand? But the adjacent side can change name. One can change to opposite side and the other one will remain adjacent side, or this other one will change to opposite side and the other one will remain adjacent side, depending on where an angle is introduced at, either at A or at C. Now look at the third shape, the third right angle triangle. We have an angle introduced at C. We call that angle given angle, even though it is unknown. It is called the given angle. It's different from the right angle. The right angle is fixed. It is angle 90. But that, whereas this one that is given now, which we call the given angle, though it is unknown, it can be any value apart from 90. It can be any angle. So since the angle is at C and is facing this side, so since it's facing this side now will change name from being adjacent to what? To opposite side, while this one still remain the adjacent side. Now look at the fourth right angle triangle, the fourth diagram. We have the angle now introduced at A, and that capital letter A is facing down. So that side, that down side becomes opposite. It changed from adjacent to opposite side, while the other one remain the adjacent side. So lastly, do not forget that any side facing the right angle is called the hypotenuse side. Okay, so now that we understand how to name the side of right angle triangle, then let us move to how to solve problem related to right angle triangle. So now I have two ways here. The first one is the use of SOHCAHTOA, and the second one is the use of Pythagoras theorem. So let me start with the first one, the use of SOHCAHTOA. Now SOHCAHTOA is not a formula. It's just a procedure, an order or arrangement that must be followed in solving problems that are related only to right angled triangle. All right, so if you look at the first letter, one is S, the other one is C, then the other one is T. That S stands for sine of angle, and then that C stands for cosine of angle, and that T stands for the tangent of angle. Now sine, cosine and tangent are the basic trigonometric ratio. It means there are others, but the basic one are these three mentioned: the sine, the cosine and the tangent. The others can be secant, cosecant, or and cotangent. All right, but that is beyond the scope of this class for now. So let us focus on this basic trigonometric ratio, which is sine of angle, cosine of angle and tangent of angle. Now let's go to the order, which is the SOHCAHTOA. Now so is SOH. That S is sine of angle, then is equal to, followed by O. That O is opposite, then the H hypotenuse. So it must be opposite over hypotenuse. That talk about the arrangement. So if you mistakenly write it in this form, hypotenuse over opposite, hello, you are looking for something else. All right, if you are looking for sine of angle, it has to be opposite over hypotenuse. That is so. It's an arrangement. Now, when it comes to the car, okay, that it there stands for cosine of angle, followed by A, which is adjacent, over H, which is what? Hypotenuse. So the order is this. It has to be adjacent over hypotenuse. All right. And the third one, which is TOA, that T there stands for tangent, or you can say tan of angle is equal to opposite over adjacent. So the order there, it has to be opposite over adjacent. So if you do anything contrary to that arrangement, hello, you are looking for another thing. It's no longer the basic trigonometrical ratios. All right, now we have an example. All right, so we have the example one here. If you look at it very well in that example one, in fact, the simplest example is that example one. All right, so now there's what we call known values and what we call unknown values. So known values are values that are known, like 2, 3, 4. These are known values. All right. But unknown values are we make use of letters to represent unknown value. In this first example, you will discover that we have two sides that are unknown. That is letter x and letter y, and they give us two known value. Hello, so for you to make use of any of the basic trigonometrical ratio, they must give us two known values. All right, so without two known values, it may be a bit hard to make use of the basic trigonometric ratio. So in this example one, like I said, the simplest, because they gave us two known values. What are the known values? We have the 8 meter and the 60 degree. All right. Now, before you can make use of the basic trigonometric ratio, you must learn to name the sides. Okay. After naming the side, it will tell you which of the arrangement to make use of, either so, car, or tour. So let us name it. And if you are going to name the side, hello, first name two of the three sides. What are the two? The opposite and hypotenuse. Always focus on the opposite and hypotenuse. Once you have the opposite and you have your hypotenuse, then the third one becomes the adjacent side. Okay, so let us go to the diagram. You discover that that symbol 90, which is we call the right angle, is facing 8 meter. So the 8 meter becomes the hypotenuse. Okay, because the 8 meter is facing the right angle. I've explained that before. And then the given angle here, which is 60 degree, is facing x. So the x becomes the opposite. So now that we have the opposite, which is x, we have the hypotenuse, which is 8 meters, then, or let me say, automatically the y becomes the adjacent side. All right. So we make use of the known value, which is 8 meters and 60 degrees, to find x. After that, you use your 8 meters again and 60 degree to find the value for y. Okay, you can't find the value of x and y at the same time. You find the value for x separate and the value for y separate. You can find any of the value of any of the two first. You can find the value of y first before finding the value of x, or the value of x first, then after which you find the value for y. But according to what I did here, I first find the value of x. So to do that now, we said x is opposite, which is O, and the 8 meter is hypotenuse, which is h. So if you look at O and h, you can get that in so. Okay, so O and h are in so. So it is so that we are going to use to find the x. That was so means the arrangement. So that x in that so is sine of the given angle, which is 60 degree, is equal to the opposite, which is arrangement. Don't forget, what is the opposite now? The x over hypotenuse. What's hypotenuse? 8 meters. So it must be opposite over hypotenuse. So x over 8. Right? So sine 60 degree, okay, in a fraction, it is root 3 over 2. Now, there are some special angles that they are basic trigonometric ratios, can be converted, their value can be converted to fraction. What are the angle? Angle 30 degree, angle 45 degree, and angle 60 degree. All right. So these are the angles that their basic trigonometric ratio can be converted to fraction. Of course, it will be explained later. It is part of the topic. I'm going to explain everything in detail later. How to memorize it, okay? How to know it offhand. That will be explained later. So, sin 60 degree is √3/2 in fraction, which is equal to our s, which is opposite, then over 8, which is what? The hypotenuse. Now, listen very well. When you have equal sign, the rest assured that there will be left hand side and right hand side. When you have equal sign, there will be left hand side and right hand side. So when you have a single fraction on the left hand side and a single fraction on the right hand side, right, under equation, equation is one that comes with equal sign, then you can make use of cross multiplication. Again, when you have an equal sign, which means equation, and a single fraction on the left and another single fraction on the right hand side, then you can make use of what we call cross multiplication, meaning the numerator you have on the right will multiply the denominator you have on the left, or the numerator you have on the left will multiply the denominator you have on the right. So in this case, x will be multiplied by 2, that gives us 2x, and 8 will be multiplied by √3, that gives us 8√3. Please don't use 8 to multiply 3 because 8 is a whole number while √3 is not a whole number. All right, so in that case, because 8 does not have root and 3 has root, so if you are multiplying the two, you place them side by side in this form, 8√3. Now if you look at the diagram, what you have is x and not 2x, meaning the 2 beside that s will have to go. What do? You will divide both sides by 2, meaning under that 2x you put 2, and under 8√3 you put 2 also. It means whatever you do on the left hand side, you must do the same thing on the right hand side. So 2 will divide 2, you are left with x, and when 2 divide 8, you will end up with 4. So 2 divide 8, that gives us 4. So the value of x is 4√3 in meters. Why meters? Because the given value there is in meter, which is 8 meters from the diagram we have there. So we succeeded in getting the values of x, which is 4√3 meters. Again, when you have equal sign and you have a single fraction on the left and a single fraction on the right, you can make use of cross multiplication. Now that word cross multiplication is not actually a formula, all right, in mathematics, okay, but we just make use of it because, are you with me now, under equation. Don't try that under inequality. When you have inequality, though you may have a single fraction on the left and a single fraction on the right, please don't cross multiply under inequality. You may end up getting wrong answers. Move to how to find the value of y. Again, you make use of that 8 meter and 60 degree to find the value of y. Don't forget that our y is adjacent, which is a. The 8 remain hypotenuse, which is h. So a and h, you can get that, okay, in that arrangement, car. So that c is cosine. So we have cos of the angle, which is 60 degree. So cos 60 degree is equal to adjacent, which is y, over hypotenuse, which is 8. Now the value of cos 60 degree in fraction is 1/2, which is equal to our y over what? 8. Like what I explained, when you have an equal to sign and we have a single fraction on the left, a single fraction on the right, just use the numerator on the right to multiply the denominator you have on the left, and the numerator you have on the left will multiply the numerator you have on the right. So y will be multiplied by 2, that gives us 2y, and 1 will multiply 8, that gives us 8. So again, from diagram, what you have is 8, what you have is y, not 2y. So it means that 2 beside that y will have to leave. So what do? Under 2y, you put 2. Then under 8, you put 2. Whatever you do on the left, you do the same on the right. I've said that earlier. I've said that earlier. So when 2 divide 2, you have y. And that's what you're looking for. And when 2 divide itself, you have 1. And when 2 divide 8, you have 4 meters. All right. So we succeeded in getting the value of y also. You use the known values to find the value of the unknowns. Okay. And you can't get the unknown, you can't get the unknown together. You get them separately using the known value. So we succeeded in solving example 1. Okay. So let us move to example 2. Thank you.